Dear students, today we are going to solve haloalkane and haloarine questions from the 12th HSC book. Okay, so let's start with this question number 7. Now, what I'm going to do today is I'm going to solve all these questions for you, and at the same time I'll explain all the concepts which are involved in these questions. So let's start. Question 1 is HCl is added to hydrocarbon A having molecular formula C4H8. So they have provided us molecular formula. To give compound B which on hydrolysis with aqueous alkali forms tertiary alcohol C, that is C4H10O. So identify A, B and C. Okay. So let's start solving this question. So we have one compound A having molecular formula C4H8. Okay. Now when this C4H8 reacts with HCl, we get compound B. We don't know anything about compound B, and they have provided further information as B when reacted with aqueous KOH. Aqueous alkali means you can use either KOH or NaOH or Ag2O. You can use any reagent. Then we get tertiary alcohol. This is the hint provided to us, and molecular formula C4H9OH. Okay, so we have to solve to get this C. Now let's start with C4H8. What we can do is we can arrange these 4 carbons and let's see how many alkenes we can draw. So suppose C4H8, now I have drawn this 4 carbon in a straight line. Now I am giving this double bond between first 2 carbon. Now in the second sequence, I am just changing the position of carbon-carbon double bond, and in the third, let's check if or by writing carbons in a branching way. So let's satisfy the valencies, then CH and then CH2. Now here CH3, CH, double bond CH and then CH3, and suppose we have double bond over here CH3 and CH3. So I have given, or I have written this three structures from the molecular formula C4H8. Now let's add HCl to this. Okay, so HCl, again here HCl and HCl. So now let's start with this first structure. Okay, so in structure 1, the alkene is unsymmetrical, because if you look at the carbon-carbon double bond, there is on the left hand side there is one alkyl group and there is no other substituent on the right hand side of this carbon. So this alkene is unsymmetrical, or how you can identify symmetrical unsymmetrical alkene is if the number of hydrogen between the carbon-carbon double bonds are not similar, you can say that alkene as unsymmetrical alkene. So let's add this unsymmetrical reagent to unsymmetrical alkene. Now we have to apply Markovnikov's rule, and the Markovnikov's rule says negative part of the reagent get added to the carbon which contain less number of hydrogen atom. So here we are going to add chlorine to this carbon and hydrogen to the other. So we will get CH3, CH2, CHCl and CH3. So we have got this compound B. Now when we react it with aqueous KOH or NaOH or He2O, then Cl will get simply replaced by OH. So CH3, CH2, CHOH and CH3. Now we have got alcohol, but this alcohol is not tertiary, it is secondary, because it is CHOH. When any alcohol is with the, or when OH group is attached to carbon which is attached to two other carbon atom is a secondary alcohol, or simplest way to identify is if it is CHOH then it is secondary alcohol. So we want tertiary alcohol, so structure 1 is not the way to produce tertiary alcohol, so this is the not the structure of A. Now let's check with the second structure. Now if we add HCl to this, now if we look at this carbon-carbon double bond, see there are one hydrogen each to double bonded carbon, so we can add hydrogen to anywhere and chlorine to anywhere. So CH3, CH2, CHCl and CH3. Now if you look at the structure B then and this B, then the two structures are same, or if you do vice versa, means if you add Cl to this carbon and hydrogen to this carbon, Cl will get shifted to this carbon, but we will end up with the same product. Okay, so we will get CH3, CH2, CHOH and CH3. So this is also a secondary alcohol, so we will not get this product. Okay, so this is not the starting material. But let's check with the third structure. So HCl, now this alkene is unsymmetrical. Now you can identify because hydrogens which are present between carbon-carbon double bond or hydrogens which are attached to doubly bonded carbon are not similar. On the right hand side there are no hydrogen, and on the left hand side of the carbon there are two hydrogens. So this alkene is unsymmetrical. So we have to add this HCl unsymmetrical reagent to this unsymmetrical alkene. So Cl will get added to carbon which contain less number of hydrogens, so to this carbon. So CH and hydrogen to the other carbon. So CH3, C, Cl, then CH3 and CH3. Now this is the compound B from the third structure, and let's treat it with aqueous NaOH or KOH or Ag2O. Now Cl will get replaced by OH. This is simple nucleophilic substitution reaction, and now we have got alcohol which is a tertiary alcohol. Now how to identify tertiary alcohol? If it is COH then it is tertiary alcohol. So I'll just write it for you. If it is CH2OH then it is primary alcohol. Okay, if it is CHOH then it is secondary alcohol, and if it is COH then it is tertiary alcohol. So this is how you can remember primary, secondary and tertiary alcohol. So now the structure of A is CH2 double bond C, CH3, CH3. So this is A. Then after addition of HCl, this is B, and after alkali hydrolysis we got this C. So this was the solution. Let's move to the second question. Now the second question is, complete the following reaction sequences by writing the structural formula of organic compounds A, B and C. So we have to solve this. Let's see, 2-bromobutane when treated with alcoholic KOH, okay, we get A, which is again treated with Br2, we get B, and which is again then treated with NaNH2, we get C. So let's try to solve this. 2-bromobutane, I'll write it here for you. 2-bromobutane when treated with alcoholic KOH, we get A when treated with Br2 we get B, and when treated with NaNH2 sodamide we get C. So 2-bromobutane. 2-bromobutane means 1, 2, 3, 4. So we have written 4 carbons. Now let's number this carbon first. Then on the second position there is bromine, and we just have to satisfy the valency, and that's it. So CH, then CH2 and a CH3. So this is your compound 2-bromobutane. Now when it is treated with alcoholic KOH, now we know the alcoholic KOH is used for the elimination purpose. Okay, so elimination means it is, let's first identify alpha and a beta carbon. So always remember, when alcoholic KOH is always used for the elimination, and for elimination purpose we need to identify alpha and a beta carbon. So functional group is attached to the carbon CH. So whenever functional group is attached to any specific carbon, that carbon is always marked as alpha. Okay, and the carbon which are next to alpha are beta. So here we have beta and we have beta dash. Okay, first remove hydrogen from the beta carbon and remove halogen from alpha carbon, or you can say this step as dehydrohalogenation. This step is called as dehydrohalogenation. So suppose I am removing beta hydrogen and alpha halogen. So we get CH3, CH. Now there is no halogen and hydrogen we have removed, so double bond CH and CH3. Okay, so dehydrohalogenation. And then if we add Br2 to this, CH3, CH, Br, then CH, Br and CH3. So we have simply added bromine to this carbon-carbon double bond. Now what we have to do, we have to treat this with NaNH2. NaNH2 means what? Sodamide. Sodamide means what? It is used for elimination reaction. Okay, so sodamide is a stronger base. So now what I am going to do is, see, halogen is attached to this carbon, so this is alpha carbon. Okay, and there is a beta carbon which is this carbon, and when bromine is attached to this carbon, okay, this is alpha carbon and this carbon is next to alpha, so this is beta carbon. So what we are going to do, we are going to remove hydrogen and halogen from these carbons. So we will end up with this product CH3C triple bond C CH3. Why? Because we have removed one halogen from this carbon, hydrogen from this carbon, and the next time we have removed hydrogen from this carbon and halogen from this carbon. So we got alkene as a main product. Okay, then as we have this two beta carbons over here, we have removed hydrogen from beta carbon. Now let's remove beta hydrogen from beta dash carbon. So if I remove hydrogen from this beta dash, CH2 double C double bond C, this is CH, okay, sorry, CH, and then CH2 CH3. So now we have got this CH2 double bond CH single bond CH single bond CH3 as a product. Now let's add Br2 to this. So if we add Br2 to this, then we get Br CH2, then CH Br, then CH2 and CH3. And if we treat this with NaNH2, then again this is alpha carbon and this is beta. Again if we consider this bromine, then this is alpha carbon and this is beta. So remove hydrogen and halogen, so we will end up with HC. So we are going to remove all the hydrogens and all the bromines from this carbon. So carbon and carbon now triple bond, and then CH2 and CH3. So we have got this product. So this was the solution for the first problem. Now let's check what is the second problem given. Second problem is isopropyl alcohol when treated with uh, PBr3. PBr3 is phosphorus tribromide. We get A, and then we are treating it with NH3 excess. Then what is the product B? So we have to find A and B. So let's write it down first. So our starting material is isopropyl alcohol. Okay, isopropyl alcohol. Isopropyl alcohol when treated with PBr3. Then we get A, and if we add NH3 to this, we get B. Isopropyl alcohol. So let's first draw the structure of isopropyl alcohol. CH3, CHOH and CH3. Now when it is reacted with PBr3, then we get Br instead of this OH, because this is method of preparation of alkyl halide from alcohol. So CH3, CH, Br and CH3. Always remember, we can convert OH to halogen, okay, with the help of PCl3, then PBr3, okay, and PCl5. So we can convert OH to Cl or Br respectively. So we have got this compound A. Now when it is treated with ammonia in excess, okay, then see, this Br will easily get replaced by this NH2. So we get CH3, CH, NH2 and CH3. So this is our final product B. Now Br get converted to NH2. So we know Br, Cl, iodine or any halogen, they are good leaving group. So this is simply a substitution reaction, nucleophilic substitution reaction. So we have replaced Br by a stronger nucleophile, that is NH2. So you need not have to write end products, but if you want to write, you can always write it. So if you want to balance this reaction, then see, we are going to replace OH by Br. And how many bromines are there in the starting in the reagent? There are 3. So we need to take 3 alcohols initially, okay. Then OH will get replaced by Br, and now what is left behind? That is there are 3 hydrogen, 3 oxygen and 1 phosphorus. So that is H3PO3. So this is the byproduct. So this is how we can solve all the series if we are clear about all the preparation methods and reactions of that functional group. So for you, I can quickly revise all the preparation methods, or I can give a flow chart to you. But before that, let's complete this question number 3. So question number 3, observe the following and answer the questions below. So CH2 double bond CH and X, and they have provided us resonance structure like this. So name the type of halogen derivative, then comment on the bond strength, bond length of CX bond in it, and can react by SN1 mechanism. Justify your answer. Okay, so let's write it down and let's solve it. So the structure given is CH2 double bond CH and X. We know halogens have 3 lone pairs and we write 1 bond to all halogens. And if we draw the resonance structure, then this lone pair will come here and we will get minus charge over here. So CH2 minus. Now because we are taking out this 2 electron on carbon, so I'm writing 2 electron as 1 minus charge, and then CH double bond X plus. Now let's see what is the first question. First question is name the type of halogen derivative. So this type of halogen derivative is vinyl halide. Okay, vinyl halide. Vinyl, how to identify vinyl halide? Whenever halogen is attached to carbon-carbon double bond directly, then it is vinyl halide. Okay, suppose any halogen is attached to carbon which is next to carbon-carbon double bond, then it is allyl. This is vinyl. Okay, so this is how we can identify and remember their names. Vinyl is simply a carbon-carbon double bond, and just make sure that halogen is attached to carbon-carbon double bond. Carbon carrying carbon-carbon double bond. So this is vinyl halide. So this is the first answer. Second answer is, second is comment on the bond length of CX in it. Bond length. Now bond length is, see, the lone pair of halogen is in conjugation with this carbon-carbon double bond. Okay, so if it is in conjugation with carbon-carbon double bond, then bond length is shorter, because if there is a double bond, the bond length is shorter. So bond length is shorter because there is a double bond. Okay, after resonance we get this double bond, so bond length is shorter. And answer to the third question is, can react by SN1 mechanism? Justify your answer. So see, we know that primary and less crowded secondary alkyl halide, they react by SN2. Okay, and crowded secondary alkyl halide and tertiary alkyl halide, always remember, they react by SN1 mechanism. Now here we have CH2 double bond CHX. Okay, so let's try CH2 double bond CH and X. So see, SN1 mechanism means it will form a carbocation as an intermediate. So let's try. Okay, if X is removed, then we get CH2 double bond CH and plus, which is highly unstable. Why? Because the carbon which is carrying double bond cannot have the plus charge at the same time. So this structure is not at all possible. So this structure will not react by SN1. It will not react by SN1. It will react by SN2. Okay, so we have solved the seventh question, complete seventh question today, and I'll quickly give you all the methods of preparations of alkyl halide from various starting materials. Okay, so now we have to prepare RX. You can prepare same chart and you can revise it daily. So let's prepare first alkyl halide by alkene. Okay, so if there is a symmetrical alkene, then you can simply add HX and you get alkyl halide. If the alkene is unsymmetrical, RCH double bond CH2 like this, then you can add HX, and the addition should be according to the Markovnikov's rule. Then suppose you have unsymmetrical alkene like RS, CH double bond CH2, and you have to add HBr specifically in presence of H2O2, then it will react by anti-Markovnikov's rule. So just remember, we have to apply anti-Markovnikov's rule. So I am writing in short AMR here, and MR for Markovnikov's rule. Then we can prepare this alkyl halide from alkanes as well, but this method we are not using because we get mixture of products and we are not able to isolate the products as well. So this method is not useful practically, but yeah, theoretically you can write on paper Cl2Br2, and in presence of H nu you get multiple products till all the hydrogens of alkane get replaced by all the halogens. So then next question is next method is from alcohol. So from alcohol we can prepare RCl specifically by using concentrated HCl, okay, then ZnCl2. This is called as Lucas reagent. So we will end up with the RCl as a specific product. So at the end of the arrow I am specifically writing RCl. Now we can again prepare RCl from RBr from ROH. If we use HBr, we can prepare this HBr in C2 and we will end up with HBr. Similarly, we can prepare Ri by using HI, and HI is prepared in C2. We can also prepare alkyl halide from alcohol by using PCl3, PBr3 or PCl3 reagents, PCl5 reagents. Okay, so by using this phosphorus trihalide reagent and pentahalide reagent, we can prepare alkyl halide from alcohol. And then there is one more method, ROH. When treated with SOCl2, then we end up with specifically RCl. This is very good method of preparation of alkyl chloride from alcohol because the end products are HCl and SO2 gas, and both are gases, so they evaporate after the reaction is complete, and we will end up with the alkyl chloride as the only product, so we need not have to go for any purification procedure. So these are the methods of preparations of alkyl halide, and there are specifically some reactions, like suppose you have RCl and RBr, and if you want to convert it into Ri, then you can go for the Finkelstein reaction, and the Finkelstein reaction is react it with NaI and acetone as the solvent. Similarly, if you have RCl and RBr, and if you want to convert it to RF, specifically fluorides, then heat this alkyl chlorides and the bromides with the Cu2F2, then SbF5 like reagent, antimony pentafluoride, then Ag2F2. So these reagents will convert chloride and bromides to fluorides. So this method is called as Schwarz method, and this method is called as Finkelstein method. So you can revise this chart and you can solve all the question papers which are related to preparation of alkyl halide. Thank you.